where you remember that D is the common difference, right? A sub 1 is first term, and n is the number of terms. And then the other one was the geometric sequence. And geometric because instead of having a difference, it has a ratio. So this is addition, subtraction, and this was multiplication, division. And this one was like this. A sub n equals a sub 1 and minus 1. And where r is the common ratio. And everything else is the same. Now, it turns out that you can have a, so there's nothing new here. The only difference is that they're going to give you things with variables. So for example, x square root of 2x squared plus 2x cubed. And they want you to find the 10th term of a geometric sequence. So you know that a sub 1 would be what? 2x. A sub 2, you know, is square root of 2x squared, which means that with these two, and what in it's a comma, sorry. It is a comma? It is a comma. And a sub 3 would be 2x cubed. So, from a2 and a3, you know that 2 square root of, square root of 2x squared equals a sub 1, which is x, r to the 1 minus 2 minus 1, right? And then this one would be 2x cubed equals x r 3 minus 1. So you can find the r for these two because you've got two variables with just the one thing, okay? Do you want me to continue or do you get the idea? You got the idea? Yeah? You good? So that's that. Now, may I erase this?
Yeah. Not that.
You should have, oh, not that one, okay.
No.
Now, there's something called arithmetic and geometric means. If you remember anything of what I've taught,
those are the ones in the middle, right?
excuse me?
The means are the ones that are in the middle.
The means is an average, okay? The word mean in statistics is always an average. But usually you use the word mean in statistics specifically for very large samples. That's why it's called mean and not an average. But in the end, what they really are is an average. But the difference between arithmetic and geometric is we said that arithmetic was addition, subtraction, right? And geometric is multiplication and division. And this is just so that you remember. You know that thing I'm always making when you multiply, you add, when you divide, the exponents. You remember this? You subtract, when you raise, you multiply, and when you root, you divide. Operations usually have a hierarchy, don't they? What's the simplest of the operations that you can think of? Addition. It's like this, that's the key and the basis for everything. Addition. Then from addition spins off subtraction because it's the opposite of addition, right? It's like the inverse of addition. And then multiplication. Why? Because multiplication is the summary of addition. And then you have the opposite of multiplication, which is division, which is a series of subtractions. So they're all related. And in the end, they're all additions. But if we go up in the hierarchy, what comes after division or multiplication and division?
The exponent.
Exponents. And then the opposite of that, which is roots. Roots. And then we go into the variable being the exponent, and then we have logarithms. So that's like the hierarchy going up. So if you think of that, the arithmetic mean,
Which one is the top?
the highest
Yeah.
logarithm and exponent when the variable is the exponent, like this. That one.
Is that not like a higher?
There's a higher.
Like
Not
a
for
prefix?
simple. Eventually there's something higher,
Mm.
but let's say for now that's it. Okay. So for arithmetic means it's just x plus y divided by 2, which you know, right? You have two variables, you have to divide it by 2. Let's say that there were 3 variables, x, y, and z, divided by what do you think?
3.
And then the geometric mean, this is the simplest way I can think of explaining this, so that you remember and never forget it, because you're going to get a couple of these in the test, in the SAT tests. And then the geometric mean is going to be easy, right? So, the reason why I explained the whole hierarchy thing is so that you don't forget this. So multiplication goes with roots and addition goes with division, okay? Now you can think of it in the hierarchy. So, if you look at example 99.6, it says, the positive geometric mean of 2 numbers is 8. So 8, right? The positive geometric mean of 2 numbers is 8. And the difference between the numbers is 30. Find the numbers. Think you can do it, right? Do you want me to know? Yeah. Aha. And it's put it and it's done. Do you need me to do it or you get it?
Yes, you can do it.
I can do it? Okay. Really simple. 64, because I have to raise it, right?
Right.
Would I do one side, do the other? X, Y. X equals 30 plus Y. Ooh. 64. 30 plus Y equals, I know this
Times
question.
y.
My bad. 30 plus Y times Y. 64 equals 30Y plus Y squared. Ooh! A quadratic equation. My favorite. So we've got 0 equals Y squared plus 30Y minus 64. And you either use the quadratic equation or you use
Find the.
factor. Okay? And you're going to have 2 answers. Got it?
When.
That means a couple of possibilities. So we got it? We good?